well-respected industry professional, and also Owasp Foundation board member. So this should be a very interesting talk. So I'm going to hand it over to Dinis, and you're in very good hands.
So first of all, I just want to do a quick disclaimer. And actually, one of the ideas that we wanted to do from a board point of view that we didn't get our heads around it was to actually, for every talk, to actually have a little text that explains the agenda of the person doing the presentation. And Mark Curfey had a great slide. It's very easy. It's very hard to make somebody understand something when their salary depends on them not understanding. So most of the people who speak here work for companies who have their own agendas, and that's in some ways is not a problem as long as it's not a massive plug for that company. But we need to understand, or you guys need to understand where the person comes from. So what I'm going to show you guys is I think a very interesting research project. And I'm going to show how I approach it, how I solved it. And what I'm going to talk about is my personal opinion. This has nothing to do with OWASP, so I don't have an OWASP hat on. I'm not speaking on behalf of OWASP. I'm not speaking on behalf of the OWASP board, and I'm not even speaking on behalf of Ounce Labs, right? Although I've done this on top of Ounce Labs, although I think they're making some interesting changes recently, this is still not the official line of Ounce Labs. Okay, so I hope I don't get any quotes from here saying Dinis from Ounce Labs said this. It's Dinis' personal opinion, right? Which is what I'm saying. So the first thing I want to show you, right, is the tool that I developed is not for the faint of heart. Right? This is like, an interesting view that I can create with this. And I'm going to go back to another image, but I just wanted to show this because this was actually the first one I developed. And I called it F1 at the time. We then renamed it to O2. And basically, what I'm going to show you is about 90% of this is open source. And I think it's very exciting because I was able to release literally the work that I've done for the last 6 months on an open source license. So there's a very interesting dynamics that can occur. So the first thing I want to say is I think, does that work? Hello? Yeah. So the first thing I want to say is something that is a bit politically incorrect, but I believe probably most guys in this room share this feeling, is that most tools suck, right? Their suckiness might depend, where you stand or what you're trying to do, but most of them, from a point of view of somebody who knows what they're doing or has some expertise in an areas, they really suck, right? Because, it's like here's somebody selling a tool that says, here's a car, and you're gonna take you cross country, and then it doesn't take into account that your travel to the cross country doesn't only have roads. You might have other things. You might have rivers. You might have, non-pavement stuff. So what the reality is that you have this crazy world where if you look here, right, in one side you have tool vendors who say, we great, buy us, press a button, there you go. On the other side, you have the consultant guy saying, that sucks because I can find much more stuff than they can. And actually, it's true. So I call it like there's a magical combination of events and frameworks and technologies and programming styles that the tools can hit a button and succeed. And like, hey, if I can do that for a project and I'm happy that the tool that I'm using did the correct job, look, I'm happy. I've done my job, client is happy, it's great. The problem is when you go back to real world applications that have real world focus and were developed by real people, it's like this. Mark Curfey had a great diagram that said the tool vendors want the world to behave like firewall, web services, firewall, database, yada, yada, yada. When in reality, the applications that we have look something like that, right? Or like this. Or, they're complex, they're interconnected, and there's a huge amount of stuff. So my biggest problem with the tools is that they were not designed for somebody who knows what they're doing. They don't expose what they're doing. They don't give you interfaces. They don't allow you to automate your brain, which is what I wanted. What I want is for a tool to automate my brain. So I want to be a fighter pilot. So I'm going to change. I like the analogy of Formula One. Unfortunately, F was quite similar to 45, which is another competitor or Armorized. So probably calling F1 was a bit too close to call. So we decided to call it O2, which is I like oxygen, which is not a bad analogy because you sort of need a lot of oxygen to handle all the stuff that this thing does. So basically, my history here is I'm a contractor with Downs Labs, right? I have a contract with Downs Labs. I'm not a full-time employee, and that's on purpose, right? Because I like my independence. And in fact, the only company I can't work is 45, right? My contract, they have a lot of it. I just take no. Okay, 45 is fair enough, but I'm still contracted with Downs Labs, and I view my role as now in-house is to solve my problem. So what I did was, after trying to use the product in a lot of different ways, I decided that the best thing is, why don't I just write something for me? Okay, so I basically took the approach of, since I can program, reasonably, I took the approach to say, well, if I can grab the ideas from Dinis, the security consultant, and pass in to Dinis, the programmer, right, this might actually be quite interesting, because I might actually be able to develop something that can really automate the process. And that's what I did. So what I want to show you, is like the toolkit that I have, which is basically what I mean, the story of a tool for security consultants. So I basically reach a point where I can now automate my brain. So I can automate what I want to do. So when I'm doing an assessment, I'm going at really, really fast speeds, because I basically play kind of best of both worlds. I have a live application, so again, just source code is not enough. You need a live application, and then you need all this technology that will allow you to analyze what you're doing. So I have the live app, I have the source code, I have technology that allows me to analyze the source code, and then I go for my test. And that is spectacularly effective, even as a team. I've done projects where we have 4 guys, 1 black box, source code, 1 on the databases, 1 on input validation, 1 overall, and it's amazing the speed that you have, because suddenly you don't waste time. When you find something on the black box, you can immediately correlate it with the white box. When you find something on the source code, you correlate it with the website approach. And the reality, if you can't write an exploit, it's not exploitable, or you're not good enough, right? If you have access to the live, to the website, access to the source code, access to everything, either you're not good enough, which usually is not the case, because usually, the guys who do this tend to be good. Either there's something else in there which you need to find out, because that might be mitigation control, or you have, or exploit, or it's not vulnerable. But for me, that's great, because it gives me a focus. And my objective is to find exploitable vulnerabilities from the website, so I can have what I call insecure patterns. So I can go to the client and explain, this is the problem. And I always try to frame it from a business point of view. So I don't say, you have data, parameter validation. I say, I can control the market if you're a stock market application. So I always give it a bit of a business kind of twist. So basically, the first thing that I did, right, and again, this whole thing, the way this whole thing works is I prototype like crazy, and again, it works really nice when you can just, be in the middle of an assessment or a project, and all this was done on top of live projects, right? And everything I'm going to show you now is open source. It's been released on Codeplex/O2. Everything here is open source. The only thing that is not open source at the moment is, well, only in brackets, but is the scanning engine, is the ability to actually run a scan, and the ability to create the dumps, although I'm going to show you a variation of that. And if you want one, right, I've been authorized, which makes me very happy, that as long as I personally support you guys, I can give you this, right? And what you do is you give me your business card, right? And I'll give you this. And this is, an eval version of that, so you can do the scans if you want. So what I want, right, is the first thing I wanted to do was to handle, what's it called? I want to be able to handle large amounts of findings. So again, what is the typical story? The typical story is that you do an assessment and you have 15,000 findings, right? Or you have 20,000, right? So the first problem I solved was, how can I handle 50,000 findings? And what was great was that when I solved that, I realized that I can handle 500,000 findings, which was great, because I found this interesting idea or concept there, where before, all the engineering was trying to create ways to reduce noise, create ways to reduce trace. I then went back and just turned up the volume, right? And created traces everywhere, because I could then filter them. And what I found very interesting on this is that what I'm doing now here, you guys can do for all sorts of other things, because what I'm actually giving you is an API to write findings in this way and to convert things from and into this particular format. So one of the interesting consequences of Ounce releasing this is Ounce just released, right, an open sourced findings descriptor language, which is, I don't think there's a lot of them out there, and one that's at least kind of as robust has this one. So this is a great way to communicate. This is a great way to send information to developers, and great way to, like even OWASP, right? Even if we don't use this, we should have a common language to describe vulnerabilities. We should have a common way that every tool can report to, and we can cross-check the whole thing. So this is how it works, right? I created this thing, and basically you drag and drop the assessments there, and then let's start running some searches. So first one, I can just find, I know you guys can't see a lot of this. Actually, let me just run the magnifier on this. At least you have half a chance to catching up. Where the hell is it? But what I have quite a lot of stuff as usual to go through. So the main thing I want to show is what can be done. And when I go under the hoods, which is in the second part of this presentation, this gets even more interesting. So this is just a way to filter data, right? I drop my assessment files there, I run my search here, and this way I'm just searching for, okay, let me actually change something here, because you guys can see that. So let me do that. So at least we sort of there. Okay, so that just says vulnerability type. I search for everything. This is a regex, so I can type, a proper regex here, and I just get a list of stuff here. Now, my whole logic was asking questions. So I have this. So a simple question: what are all the sinks, right, that exist? Okay, there we go. What about the lost sinks? What about the known sinks? What about the files that it loads? What about the sources? So everything that I was adding here was that I literally was doing an assessment, had a question, ooh, I want to do this, and I would stop, like pause that, go back, add the feature, come back, and then continue the assessment. And it worked really well, because I was only developing features, right, only in brackets, because there's kills of them in there, but I was only developing features that make sense. So what I found interesting is that, instead of having a committee somewhere thinking about, oh, assessment filtering, how should we do this, right? And asking somebody going, okay, what do you think, right? You want assessment filtering. And then they taking down the spec, and then they programming it, and then they QA it, and then they go back to the other guy, says, this is what you want? He goes, that's great, but actually, can you do this, this, this? And he goes back again, and he goes. And then 2 months later, he goes back. So basically, from my view, is that I implemented what I wanted. So the idea of open source, you guys should do the same thing, right? You guys should mold this to the way you want to think. And probably a lot of the functionality you want, it's already in there. So a lot of these things, it's all about gaining you 5 seconds. Like in my view, if I'm using a tool and the tool makes me move my mouse over there, right, to do something and then there, and I have to do that 5 times, and it costs me 5 seconds every time, I'm losing a minute every time I do that. Because every time that I lose my flow, it takes me back time to actually regain where I was. So I would love to have a Minority Report world, right? My perfect model is like, you have this massive screen, and you're just like flowing things around, and you're grouping them here, and you're throwing them there, But that's how you think, right? That's how your brain works. Your brain works by making connections. So the tool's job should be to give you all these kind of pointers, and you can go, oh, follow that, follow that, follow that, and then give me the results. Yeah, that's good. Follow that, cool. And then, okay, I got one, throw it over there, and you keep going. And because that's how, at least my brain, kind of works. So this is just a very simple view of the information. So here's a very simple trace, right? Let me just clean this up a little bit so you can see more of the things. So, and again, like I was able to really experiment with the way these things can be displayed. So I was, and this is, easily version 5 of this GUI. So my rule of thumb is that if I can go to an engagement and not have to add any feature, I sort of got a mature control, right? And it takes like 3 or 4 engagements for that to happen, right? Where you're not really adding anything substantial to it. So here is one of my favorite features. And this is one of the things that I really started to play with, and I'm really interested, which is visualization of findings. So the Owasp technology and the Fortify and Armorize, or whoever's doing source code analysis today, and Microsoft and IBM, joined the party, so it's quite interesting, right? Market at the moment, and HP, some stuff, whatever. It's like you need to follow tainted data. The whole point is I have a source, I have a sink, right? Something happens here, and there's something that I shouldn't be arriving to, and the job of the tool is to follow the data. That's his job. Right? The job of the tool is I grab the building, I mark all the entries, I mark all my assets, I run the tool, and the tool finds me the paths. That's his job, right? And it's great because I don't want to do that. So my job is to find all the entry points. My job is to find the patterns. My job is to find the crazy, reality altering functions like reflection, which means like the hyperdrives or hyperjumps. Right? So you're coming in here, and then there's like Ajax, and go, hey, look, I can grab a value from a string and jump you over there. Oh, that's cool. So now my data now is over there. Then you go here, and I'm going to call a web services. Oh, cool. So now my data is now over here, right? And then this web service is going to call a database, and now my data is over there. So I view as my job to glue these two together, so I can have a big picture. So I can grab all the different components, glue them together, and have a very big understanding of what the app is supposed to do. So here was one of the questions that I had when I was, performing this assessment. So I'm going to do a sync. So I want to find the ones that have SQL injection. So I'm basically running a script that says find me all the all the findings that have a sync with SQL. So here is one of the things. Wait, sorry. Okay. So here is something that is quite typical. Okay, the way you read this is basically, you see the numbers there? So you go 0, 1, 2, 3, 4. So that's, the numbers tell you the call sequence. And it's one of those things that they might not be as obvious, and there's a bit of a problem that every graph looks different. So, sorry I didn't have the time to make this all consistent, but it really works because, again, that's how you want to read it. You want to read in sequence, right? It's all good that you can make all these great, trees or whatever, which is, it's good. But when you're doing a lot of assessments, I like to see in sequence. But even more importantly, the big questions here, right, is what are the patterns? Like, why do I have to, right, read every single one of these traces to see what they do? Right? Why do I have to consume, mental power to go through all this? So the first things I start saying is like, actually, I can clean this up a little bit because maybe I don't need the parameters, and maybe I just want, not all the namespaces, just one namespace. So there you go. It does clean up a little bit, makes it a bit more, sweet, but it's still the same problem. So again, what was the question I had? So what was the question security consultant Dinis had? Can't I just plot them all at the same time and then look for a pattern? So that's what I did. And a lot of these GUIs are literally like I was coming up with an idea and I was fitting the button in the GUI so I had somewhere to press. So there you go, multi-nodes. Now this is interesting. So instead of now this number saying the sequence, this number now says the number of paths that go through those particular nodes. So now this becomes more interesting because I can now plot a lot of graphs on the same drawing. And now it becomes interesting because you're now looking at patterns. So now what's the next question? Actually, right, because the way this works is the blue ones are what's called taint propagators. They're functions that data goes through. This one's here, you can't really see, but there's actually two different colors. So that one are what's called sources. They're the places where data comes from. And this one here, the red one, which you can't see, is the sink. So what's interesting is I have a whole bunch of different sources all arriving at the same sink. So that's interesting. So what's my next question? Can I just take all the blue guys away? Because in principle, they propagate taint, so I don't really need to see them unless there's a validation routine, which is why you go to the black box. Because this tells me that data should go from A to B. I can very quickly verify that. So you can go and like, well, I don't see source and sink. And now, if that works, let me clear the graph. Now this becomes more interesting, right? So now my view only has the sources and sinks and gives you a little dot for every path. which is interesting because you can see some patterns, because you start seeing things that look like this, means that there's going to be 1 or 2 points, which is, again, what you want to tell the developers. What I like about this is I can grab 20 or 50 findings, plot them all in the graphic, and then tell them, it's here you need to fix, right? That is the soft spot. You fix that little guy there, you fix all of this, right? And I like that because I'm proactive. I'm giving something to developers that they understand. I can get them to fix the thing properly. It's great. Or you might have one where it's like this, and you go, guys, this is not going to work. You're going to have to change the architecture because there's no way that I can tell you to fix this in 2 things because like every single one is a problem, right? So again, what's the question? Can we just drop all the little dots? Because I don't really need to know them. So what I want is this, right? And let me just redraw this again, because it's going to be easier for you to see, is that. See, I love this view. This is a view that is mapping just source to sink. And it works really well because all I'm viewing is now all the places where tainted data comes from and all the places that tainted data arrives to. And I'm just viewing those. So this becomes a spectacular analysis because you can literally plot hundreds or thousands, right, of this. Okay, it grows a bit bigger depending on the names, right? But again, you're starting to see very nice patterns. You start to see a lot of interesting components. And also it becomes very easy to do things that sometimes is hard, which is to say, okay, I don't want anything from the local disk to be treated as source of tainted data. If you're reading a config file, drop it. If it goes into a log thing, drop it. And that becomes easy because that's just going to be one of those things there. And I can script all that, I will show you, but this works really well. And again, remember that in order for you to visualize it like this, all you need to do is write an XML file. So one of the things I would like to do is see if I can grab some Qualys findings, right? Or, other scanner findings, and then convert it to this. Because I can analyze them like that. I would love to be able to map a WAF output and map it like this. Because it's now a matter of translating. It's a matter of defining what am I after, what do I want to see, what paths do I want to view. So let's see this more in action. So, okay, this one here, right? This graph here, what you have is, so if you look there, where's my mouse? Okay, so what this is get account detail with using account ID, get account, blah, 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 all of those, right? Request a loan. Okay, every single one of these, right, is a web services method that is arriving into an SQL entry point. So those are all my web services that are vulnerable to SQL injection. And that's what that graph means. So what I want to do now is, okay, so my web service is not in good shape. Okay, but I have a website that's consuming my web services. Now, are every single one of those vulnerable? Okay, in WebGoat, so in HappyBank, you could argue that I might as well fix it. If you have 300 web services methods, right, it's actually not a bad idea to prioritize by the ones that are exploitable today. So how do we find the ones that are exploitable today? Well, let's look at the website. So I already loaded both assessments here. So I already got the website and the web services assessments loaded at the same time. And again, I've loaded like 500 megs of assessment files here, right? And because I can filter them quite quickly. So I'm going to find a sink which is called invoke. So this sink, what it does is, okay, again, it's quite clean, right? So if I just do this, okay, what do I know now? I know that every single, that simple graph is telling me that every single connection that has tainted data that coming from the client that reaches a web service only comes from 2 sources. A query string, right, and a get text. So immediately I was able to very quickly identify that. So because you can see here, right, what's happening is that I got my get box, which is going into my get account details, which is going to my .NET wrapper, which is going to my invoke. Now here's the question. How do I now know which web service is called on the other side? So one of the cool things that at least, Ounce gives you in the engine, but you could find this out other ways, is that if I look at my sync, what's called context, the engine is already resolving, and let me make a unique list. It's already resolving the get account details. So you can see that this list that I have here are the lists of the web services methods that are called from the web's layer. Now this is cool because now, again, if I was scripting this, and I'll show you how everything here is scriptable, I would write a quick parser just to get that information out. So that's pretty good. So now I got my entire list of web services. And you think about, like, I'm doing this, like this is my chain of thought. This is how I think about these things. So at the moment, what I like about it is I'm not being limited by technology. All I need to do is tell the technology what to find, what to go after. So here, I want to, let me find the login. So I'm going to go for trace context, right? So the trace, this means I'm going to search on every single trace. Any one of those trees, I'm going to do a search for the context that uses login. So let's see what we get. So we get a bunch of findings, right? So let me plot that for you. And what we got on these findings is something like this. Let's just clean up, make it big, and then we clean up. So what we got here is, right, this is the web layer, right? So get text, create user, invoke, right? And this is the web services layer, right? Login, validate user password, concac, blah, 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 right? So what I got on that picture is actually the two layers together. And then I can actually glue this together, and I've done that for some other assessments, where actually I create a nice big trace. Sort of sometimes easier to visualize. But this is pretty cool, because that means that I have the two layers, and again, I don't need to see all this, I just need to see this. So this tells me that I can, via the login web services, I can put my payload on the get text. And again, you go to the black box and you put it there. If it works, it's great, because you just, in principle, validated the whole pattern. So I call this insecure patterns, where I don't think about 20 cross-site scriptings, like 50 SQL injections, right? No, I think there is one SQL injection insecure pattern in HAPME Bank. And this is it. In fact, there's a couple more, because there's a reflected SQL injection. So that will be a different pattern, where it doesn't come from the outside, it comes from the database. So I found that this is a great way to view, and there's a lot of other stuff, like you can save each individual assessments, you can create multiple assessments from the findings. There's a whole bunch of things that you can do here. So this is the first one that I want to show, right? Now, the second one, which for me is, it's one of those things that I think the story, it just shows that sometimes the product teams don't really understand what the guys on the field want. So when I was explaining how Ounce works, is Ounce basically grabs the source code, creates an intermediate representation of the source code, processes it, and gives you the results. Right? So my question is that, what happens to the intermediate representation that you just did? We dumped that. So I was like, okay, that's actually not good, because I want that. So is there any way I could have access to it? Oh yeah, there's this undocumented setting that you could use, but you don't want that. You don't want that, don't worry about it. So I was like, okay, just which one? Cool. So when I went on my detour, right, when I was like here on this other track, development track, I actually really explored this, because having the capability, and I will show you that in action when I show the Spring MVC stuff. Having the capability to have an object-oriented, right, model of your application, it's like, it's not just useful, it's actually critical for what you want to do. And again, what I'm really happy is that Ounce also released this open source. So actually what we also have today is a standard, or at least a standardized, right, way to represent source code. So I already start playing with ideas to convert other things into this, because I have visualizers, I have analyzers, I can script this. So I want to be able to scan Klingon, right? Whatever. I want to be able to scan anything that can throw to me, because all I need is a little parser, at least to have visibility, right? And of course, there's a big difference between having visibility and having the ability to follow tainted data. But at the moment, a lot of the times, it's like you have no visibility, right? Or you have regexes, and that's it. So let me show you how this works. So the way this works is, so here's all the classes. So I'm going to pick a class called Data Factory. So this is every single function that's called from the Data Factory. So no problem. You get this with 2 lines of reflection in .NET or Java. So that's not that hard. But this starts to be more interesting. So this is all the calls that are made from everything, every function on those classes. So this becomes more interesting. And what's interesting about this is that a lot of the times you can already do assessments just by looking at that, because that is already telling you the attack surface. So if you're looking at, for example, a .NET application or a Java file, a Java project, and you start to look at like when they have components, let's say they might have user controls in .NET, or they might have servlets, or might have objects, just looking at what type of APIs you need is really critical. For the ones you know that have a bit of a thing for sandboxing, right? This is one of the ways I feel I'm going to solve the sandboxing problem, but really be able to model the whole thing. So again, this is still a bit of a problem, because okay, I know that all the calls that are basically called from here. So here goes the question that usually takes you to either Eclipse or Visual Studio. It's like, okay, so who calls this guy? So I got this execute command, SQL command. So I go, okay, it's called by the SQL server, and it's in here, but who calls this? Because I found something which is juicy. So I've implemented, right, because now I have an object model, exactly that. So what I'm going to show you here, let me just pick the same guy again, is the two views that, for me, are absolutely critical when I'm doing this analysis. So where's my data factory? Okay, there you go. Okay, so this is what I want to show you, okay? So first of all, the straightforward, this guy calls this one, who calls that one, who calls all of this. Interesting, you can go down. Gets more interesting when you higher up on the application. But this one is the one that I really like. This is the reverse call. This is the is call by tree. So what this means is that, right, this guy is called by all of this. And this guy is called by that one. And this one is called by this one, is called by that, and then etc. So that view is critical, because that's a lot of the times what you want to know. You find you're navigating, maybe you did the black box, maybe you go on there and you hit one of those methods like, whoa, what's going on here? Why this guy's using this? And then you want to have a full picture immediately of where is it used, who calls it, where is it consumed. And then I take this a step further, because I use this to drive my rules. So what I use is so take this example. So the problem with this is that this is call flow. So if you actually map all this, you'll find that you have stupid amount of possible traces, because this is just a stupid call. I know that within this function, he's going to call that guy. So if there's an if false here, call, he will still have the mapping that you're calling that guy. So, but I have access to an engine that does data flow analysis, right? Great. I just tell that engine, right, to do that analysis, right? And to be honest, there's no reason why, you guys can't use this, right, to fire your rules. Other vendors or other open source tools can use this, because now the question is, can you now trace if there is a data path between here and there? Because that's the vulnerability. But this allows me to identify the attack surface. This allows me to, for every function that exists here, have a very clear picture of what is actually going on. So for me, having access to object-oriented, a version of the source code is absolutely invaluable. And what I'm going to show you next is how you actually use this in practice. So how I actually use this to implement real-world scripts. So just a last couple of things that is already also published, which, it's, again, one of those little things and one of those little tools that, for me, saves my life every day. In fact, I even use this now, when I'm not, okay, hand me back, there you go. So as my source code, here. So this text search is literally just, you can tell what file you want. So CS, so you can load everything. And then I can just load all the files. So, and then you can just regex the thing. So you can go import, right? Or let's say the login. So if I want to find the login, you can find it through here. And then that tells you on the source code where it is. And it's one of those little things, but that makes such a big difference, especially because one of the, let's say, assets that I feel I have now, or one of the capabilities which I never really had, was I now am starting to be in positions where I'm actually confident that I've made a good analysis. And this is the big elephant in the room, right? Because I've done analysis when you get given like 500,000 lines of code, and I always use technology, and the client goes, so did you look at everything? Is everything okay? And you're like, well, look, I found all this stuff, right? It's cool because I got all these vulnerabilities, but I didn't have time to go everything. So I always have this problem that I was never really confident that I covered the law. So, but I don't trust the engine. So my world is, I have my CIR dumps here, which is the object model. I have all my traces, like with the volume turned up here. I have my regexes here, and I have my black box. That's my world. So let's say I find a problem that in one of them, right? Okay, I identified, and I go to my traces, and there's two instances of that. So I will go to my regexes and search everywhere, and only expect to find those two instances. And when all this world matches up, I'm confident that I found everything, at least on that pattern. And this is like, it might not sound very important thing, but for me it was always a big problem. The fact that, I was not sure that I found everything. I was not sure that that particular pattern was, only the one that existed. So, because this is the catch-22, right? You go to the client, you give them two traces. The client is absolutely expected to ask a question, which is, so if I fix those two, I am secure. And up until now, I wouldn't really say yes, because I had that cozy feeling of like, whoa, yeah, well, I think you are. Well, you'll be better than you were before, but, there's always that thing. So, unfortunately, so this is where it is. You can download this today, right? If you give me your card, I'll support you guys on your adventures using Owasp. Owasp would actually release kind of a more formal evaluation version, so you could also have a go at it. Right? I actually hope that everybody here does the same thing. Like, why can't I just walk into one of the guys and get an evaluation version, right? I'm very happy that finally I'm actually working with a company that actually doesn't get you to sign NDAs and actually gives you the evaluation versions, or like this, and actually at least lets you try the thing, right? Even if you don't buy it, just use it open source. At least try it. Like, I don't have the other evaluation version of the other guys, and I wish I had. So, okay, so now what I want to show you is the more advanced use of it. Unfortunately, a lot of it is still on the F1 world because I haven't ported it, because also a lot of it is also to do with live engagements. But I have a couple of ones that I can show you. So we can go back to the first one that I was showing you, which is that one that has the big fluffy graphic. And what that is that's a visualization of the source code. So one of the things I started getting into was this idea that actually if I visualize something, the leaves and the leaves at the top and the leaves at the bottom are actually really good, because they're actually telling you the attack surface and the exit points. So I found that I can also do a lot of very interesting analysis just by looking at a particular graph. So what you have here, right, is that graph. Now, you might look at this and go, well, that's really stupid. You can't really do anything with it. But what if we look at it from a class point of view? So let me filter this, right? Instead of having one, I'm going to go two. So I'm now going to start filtering by class. Now, this is interesting, because if I show you the vertices here, right, what actually you have now is a relationship between, like, so one is org OWASP lessons, 2 is Java, 2 is org Apache, right? 7 is JVX, etc. So this is interesting, because now you can start to analyze this per namespace. So we're actually now looking in architectural how the application works. And what's cool about this is that if you have a data layer here, and you have a business layer here, and you have a GUI layer here, and you plot this and you see a path from the GUI to the data, you go, whoa, that shouldn't be there, right? Because that's a shortcut. So this is one of the things I can do here. One of the other things that I do is I script like crazy, right? And this is now it's going to allow me to show you, right? For me, hopefully this thing compiles, right? My favorite feature of F1 or O2, So, like, one of the things that I never forget, like I was with Ounce Engineering, right? And the guy said, okay, Dinis, I get the point, right? You need to be, what's it called? You need to have access to these things, right? So what do you want to be exposed, right? And you guys probably know that my answer was everything, right? I want every single thing that exists in all of the technology to be exposed to me. If you can do it in a GUI, I should be able to script it. So that's what I did. So what I did was I come up with this concept of why don't I develop O2 in O2, right? Why don't I able actually to, while I'm doing it, instead of going to Visual Studio, right, whatever, I just do it there. So I added this really powerful scripting environment where you can do like this. So here we go. I added the method. I compile it, right? No errors. It gets added to here, and I can invoke it, right? And I can go string. So I can basically now return, what's it called? Return something. So now you can see that it already executed. And again, why do I have to click there, go there, and execute it if I'm debugging this? So I just automate the thing. Yes, it's a little bit, you can do it, but it saves you like, 10 seconds every time. So again, I can add a string here, and I can basically go AAA. So now you can see that my parameter now is there, so I can go AAA there. So now I can put something here, execute it, and it goes already. But again, I have total access to the internal object model. So look, here's my debug view. So I can come here and I can go debug, message, debug, AAA. Now I run this, and you can see it already shows there, right? And again, I have access to the entire object model. So when I'm coding this, like load serialized F1 object, like every single thing that's available on the GUI, it's exposed here. So you can script the whole thing, and it becomes really powerful. So, I was in Black Hat. Bruce comes to me and says, okay, let's figure out a way to do, so what's it called? To do Java, the Java J2E scans. So let me just find it. I had it here. Sorry. Okay, here we go. So I wrote, right, and this is basically the way a lot of engagements works. I wrote this little script here that what it does is basically grabs the file. Basically, it's going to grab grabs this file here, parses it, adds those, has custom rules, reruns the scan, and gives the results. So this is also great because this allows you to perpetuate your knowledge. Once you crack something, you can just document it. And now, almost like you just created an engine that supports that. And it's really powerful. So I use this all the time. So a long time ago, I realized that I was always going to script on engagements. There is no way around it. So the only difference is before I would script on top of code and regexes and whatever library I had. Now I script on top of object models, regexes, scannings, and the ability to even do more scannings. And this becomes really more powerful when you do, when you start manipulating the CIR, when you create converters for the CIR into other things. So just as a final example, I want to show you this, right? So I'm not sure if you guys heard about the Spring MVC research that we did, right? While I was doing, while we published ounce, and basically, this is one of the things I developed. So when I was developing the Spring Framework stuff, was that I needed to visualize. I don't know how much you guys are comfortable with the Spring Framework and how it works, but basically it's sort of a typical problem that you have, right? A bunch of XML files who mapping to a bunch of classes over there who are supposed to be implemented a particular type of class. And then I will give you the name of the variable or the class that will be received the data that comes from the outside world. And that might actually be used in ways that the developers don't expect. Now that's the one that I give a top price for the guy who can find that generically, right? You can't, right? So what I did here was I wrote, first of all, a bean visualizer. It's like, Java guys love to create these crazy XML files everywhere. I was like, no, I like nice lists, right? Especially because you can spread it across everywhere. So I wrote a bean visualizer, first thing, so I can get everything, so I can map the outside world. Then I grab all the Spring classes, because remember, I have an object model. So my object model tells me who implements. So it's very easy to transverse that, to find out all the guys that actually implement the Spring MVC. So from here, I need to go into each one of those that actually implement the form MVC, form backing object, whatever. I need to go to this constructor and see if they set the set command name. And if they do the set command name, I need to look at the variable value that they do. And that tells me, so I do all of this just to find out that in this this is the example that they give on the Spring Framework. You download Spring Framework up until a month ago, you get this example. So all of this to find out these two names, account form and order form, and that class. I had to do all that work to find that out. Now try doing that for an application that has 500,000 lines of code, right? You can do it, but it's a pain in the ass, right? So what I do then is I then visualize that, because remember that I have an object model, so I can show you the object model for the account, and I can show you the object model for the, for the order. And here's the vulnerability. I then added all of this as rules to the engine, and I run the scan. But here you can immediately see some of the problems. So if you look at this, right, you can see, for example, here, the credit card, where is it? Set total price. So check this out. So the way this works, on Jetpad Store, there's a wizard, right? You choose what you want, you enter your credit card details, and you confirm. The problem is that they populate in the same object all the time. The problem is that Spring MVC would dynamically bind every time you submit to the same object. So what I do is I buy something, right? Then I confirm using some credit card details. And then when I submit the confirmation, I call this set total price. So, and then I can change the price. So the problem, the advantage of this is I'm using almost like a combination of analyzing XML, grabbing the modeling of the actual source code, finding out all the potential entry points of malicious data, running a scan, analyzing that, and get a nice juicy set of results, right? And for me, that's real world apps. So, the difference between this and an authorization problem is I need to check if there is a second call down the line that is an authorization call. The difference between this and almost other variations is just a formula. So if my view is that if a human can find it, I will find it and I will script it. So for me, I built an engine that matches how I want to work. And it's not nice, it's not easy to use, but once you use it, it's like driving a plane, or flying a plane. So hope that made sense. And have time for questions, or? Okay. Anybody has?
So can you explain the relationship between, obviously, the closed source ounce tool and all this stuff? Like, I can see regexes you can use on your own, but how much of this other stuff can you use without ounce underneath the hood?
The thing that you can't use without ounce? So the thing you don't have here is the ability to follow tainted data, so the ability to create the traces, and the ability to create the CIRs. But actually, I'm releasing a tool that will give you a very base CIR for .NET. Because, for example, right, the way this works is the CIR dump occurs during scanning, and I would sort of analyze the .NET framework, and I needed to model the entire .NET framework. So I actually build a CIR converter, which actually is generic. So I'm actually going to publish a CIR that will allow you to go to any .NET component and just create the data that you can then visualize it. So, for example, if you can do this for Java, you actually don't need the scanner to perform this type of analysis. And I think, yesterday I was talking to a guy from PHP, and it's like, hey, look, if you guys can convert, they're already halfway there. So look, if you convert your opcode into this, you get all the visualizers for free. Because ultimately, the way this makes sense from an ounce point of view is that ounce also needs the visualization. Also needs to know all the entry points. So ideally, I would like the Spring framework to develop those bits, because they know all the backdoors that exist on that thing. They know every single crazy functionality that they add to it just because people might need it. So that should be created by them. So I think that the dynamic at the moment is that the bit that is not open source is the actual capability of running the scans. And actually, it'd be interesting if other vendors, right, like actually also said, hey, we can plug in, right, and we do the scan. So then, hey, the best scanner, wins. And we should have an open source version of it, which actually, I think Owasp, we had the Horizon, and I want to see if I can plug that so he can also do some scans.
Will this work with languages such as Ruby or Python?
You mean the GUI? Yeah. Yeah. Well, hey, I want to expose this by Python, so Python, yeah. Well, you need to build, to analyze IronPython, you need to have the converter from Python into the CIR. But the view is that if you can do that, then you can start to visualize this. And sometimes the complexity depends on language. Like if you go to C++, it's not just following data, right? It's like buffer overflows. There's all sort of variations that, depending on the language, the engine needs to be more or less complex. So yeah, I hope that I hope that what we then have is like this kind of huge, large set of kind of parsers that can bring into this. So we have way much more visibility into all these other languages.
Hi, the tools continue to evolve, they get better. My gut feels are 35% maybe of what a human can find. So it's been an evolution. Do you foresee a revolution at some point with how these things work so that we can get closer to approximating human?
Well, see, I solved that problem by not having that problem. So I'm not saying that it's the human versus the tool. I'm saying it's the human with the tool, right? That's the way I do it. So at the moment, I'm saying that I find 100% of what the human finds because I'm the human, right? In fact, I may argue that I find 150% because I have more capabilities. So, and one of the things that I think is important, like from a client point of view, right? You can't give this to a client, right? There's no way, an end user can use this. But what you actually are creating is a customized version of the application that actually the client wants to buy. So the message I was trying to model to create is that we should be working together. This is not about fuzzers versus black box versus white box. It's like everything. It's like you need everything that you can get and every resource you can get. You need to analyze everything from all angles, right? And then to have a definitive answer. But then what I like is the concept that we actually create that one-click button, because that one-click button is the one that can be integrated on STL. Right? You can't put something on STL that's going to generate 50,000 findings, but you can create something on STL that can create 10. Or you can create something on STL that the moment the guy goes off, you get an alert. Mr.
So I'm a really big fan of this, of course, and we've been doing the same thing as well behind the scenes, and hopefully we'll get together and unify them today. My experience is the tools get about 17% of the total problems, not 30, and that's all the tools. You've built this, we've built our own on top of Eclipse. Eclipse and the IBM guys are building their own. I think there's a tremendous capacity to give this to thought-leading clients. DTCC is one client that we've had that started with Secure's tools, is using Fortify. They have a rich commitment to actually doing the client-specific things that they need to find more than 17%. Other organizations are too. To this guy's point, there's a question of, well, do you support this, do you support this? And you've built this all on your own. You're a wicked fast coder. But to what extent do you think that this should actually be integrated from a market perspective into Eclipse and actually become part of the process as opposed to these separate things that, because we have our own separate thing too, and it becomes unwieldy, right? So we spend our time developing these wicked tools, and they meet our needs, but they're not, so I guess comment on what the opportunity for penetration on this is until we get into a more common platform.
Well, see, I feel that I landed here an example of a common platform. So there is, what we have now here is a common language. As long as you speak CIR, right? As long as you speak, that safe assessment file format, there's no reason why this is not built in Eclipse. In fact, one of the big things I always felt that should happen is that every framework and every application should be providing their own code scanner, because they're the ones who develop it. So in that idea, of course Eclipse should have a built-in model of this, right? And not just Eclipse, every framework that is built on it should have it. So, we should be able to solve that problem. Or when you start to integrate the frameworks together and you start to put things on top of each other, you have some kind of context. So I feel I've done one of my parts, which is I've put outside, basically a model that can be extended. So, it's like you want to do Python, it's doable now. Right? It's like all you need now to do is 2 modules, and then you have actually all the infrastructure. So my hope is exactly that we trigger that kind of community-driven development. So when I need to have velocity support, I don't have to write it. I just go to the guys who wrote velocity and download the parser, and that gives me visibility to it. When I give any kind of things that gets thrown to me, I can implement it. So that's my hope. So I hope that with this we can kickstart that process and really have a kind of more community-driven source code scanning environment.
So it's it sounds like you're kind of touching around the key point here. You've mentioned a couple of things that are related to what I'm going to ask here, but do you think we need to start moving towards writing code that's designed to be statically analyzed as opposed to trying to make our tools work for the code?
See, that is a very key point. One of the things that I realized, it's sort of like, let's solve a problem at a time. So yeah, if I'm giving a client the way John is describing, which is really mature, really wants to make a difference, of course I'm going to say, you know what, if you can add metadata to your code, if you can start to describe from a business point of view what your code is supposed to do, I can do a much better job, right? If you can tell in your code where your assets are, so I can actually know where they are. If you can mark your code, your authorization models, your authentication models, so I can scan for it. And what's interesting is that some of the frameworks are doing that. What I think nobody is doing is visualizing that stuff. So even there's these things where you can use these XML files or these attributes to map up particular things, but that without a visualizer doesn't really work. So my ultimate, I think, kind of model is that, of course, we should be getting the application to actually self-describe itself. In fact, we should have models that force the applications to describe itself. And if they don't describe it, it doesn't work. Like, if I can't model, there's no input arriving on it. If you tell us you want a string, guess what? You're not getting anything. Or if you tell you want a string with this validator, then I'm going to give you something. So what I like about the fact is that there's a whole raft of discussions that can happen now because we can be talking about models and paths and code flows, right? My 4-year argument with Microsoft, right, which I'm sparing you guys, this couple of years, is like sandboxing, partial trust, right? Why don't we have it? Why don't we, why everything runs with full trust? Even the Java sandbox is a joke these days because it's like, can I own you, please? Yes, great. Right? It's like, but I understand their problem. The problem is that they can't model. There's no easy way to look at a Java applet or a .NET applet and immediately get an accurate thread model or understanding of what the hell is going on in there. So at the moment, it's like, well, everybody does it. It's cool. It's still under control. The user said yes, so it's his fault. So good, right? So this, in my view, it's like that's the next problem I want to solve. Like, I want to solve the static stuff. There's still a bunch of things I want to add. And once this kind of matures a bit more, I want to look at sandboxing. And I want to use this to dynamic sandboxes that can have context, right? Why the Firefox plugin don't have a freaking sandbox, right? The gadgets, it's everywhere. This world where you just have this thing that goes from there, and then you said yes, so it's your fault, and then poof, there you go. Full access to your resources. So I think there's some very interesting stuff that's happening. So please help me contribute. It's open source, right? Apache 2 license, so you can actually use it on your products or whatever, the limitations that don't exist with Apache 2. So please contribute, and we need to talk. Cool.
All right, thanks, Dinis. And we'll be setting up quickly for the next talk. Over here, Sean.